This is a demonstration of an advanced trigger mode on the 9211A sampling oscilloscope called pattern sync trigger. So at the moment I have got connected onto channel 1 a high-speed random data sequence. This is actually an STM4 signal, again clocking at 622 megahertz. So here we see random data, highs and lows, producing an eye diagram. So if we go back to the trigger menu, at the moment we've got a standard external direct trigger. Could have selected the 10 gigahertz prescaler or clock recovery, but we're going to, in this particular case, go to more and see this advanced trigger mode called pattern sync. So selecting that, so what this is going to do is going to look through the random data sequence and look for a repeating pattern sequence. So I select auto detect, and here it is looking along the sequence of data, and indeed it has found here a pattern length of 127 bits when the bits are repeating. So I go back to my main time base, and we can look at the individual pulses now because it is triggered. I will change the display mode now to vectors as we've got a stable trigger, and we can see the shape of each individual pulse, and again bringing the sweep time to longer periods, and here we can actually see now the repeating sequence, the 127 bits, and then the pattern sequence starts again. So there we can see 4 cycles of it. So increasing my faster time base sweeps, in fact I will select auto scale at this point to get my best vertical resolution. So going back into the trigger menu, we've got a feature here called eye line, and this will allow the firmware to scan through on a triggered mode each of the bits. So we've got starting at bit 0, scanning the 127 bits. I will turn on the eye line, and here we can see it scanning through the 127 bits of the sequence. So now that I'd like to perform a mask test against this data, I'm going to create a mask. So this is a standard signal, STM4 signal. So I say OK, and here we see the standard mask, and this signal is passing the mask test at this point. So I'm now going to change my display again back to infinite variable color grading, so we can watch this signal and see if there is any overshoot, ringing, or any individual pulses not passing the test. And indeed at this point it looks very good. So I can control my source here, and I'm going to switch in an error bit. So I've now switched that in, and indeed now we can see that there is an error bit here. So we've got a bit going from high to low, passing right through the mask, and also there's a late edge here swinging from low to high, not passing through the mask but still a late edge. So what we can actually do now is force the instrument to make a test on these error bits. So I'm going to go back to my trigger menu. So we select trigger, here we have the trigger, and go back. So I'm now going to go into pattern sync again and force a trigger against the mask. So on my mask test, go here. So I want to perform a test against the mask, so I'm going to select my utility. So I want to select, in my case, failed waveforms, so I'm going to select 425 waveforms. So I come back here, I will stop the test, clear my data, I'm going to turn on the test, and here we're going to see the acquired waveforms and the number of failed waveforms. So I now run acquisitions, so we can see the number of waveforms building up and the number of hits we are getting into the first polygon. So we wait here, and now it has acquired 425 waveforms and stopped. That was the test that we selected. There were 425 waveforms, and we can see the number of hits that we actually achieved into the fail on the mask at that point. So this is a way of using an advanced trigger mode to search through a random data sequence and look for possible errors in the data sequence.